Right triangles are triangles with a 90-degree angle. Okay, so let me call maybe this bottom part of the triangle, let's call it a leg. Let me call this A. And then the other leg, let's call that B. So then the side that's opposite that 90-degree angle, let's call that C. Okay, we've seen before, let's call the Pythagorean theorem. And that states that the square of the legs, their sum, is equal to the square of the hypotenuse. So A squared plus B squared is C squared. Now since we have a 90-degree angle, the other two angles have to be less than 90 because triangles add up to 180 degrees. So that means one of these angles, either one, is less than 90. So what we can do is define our trigonometric functions of acute angles in the following way. Recall that acute, I call it theta, is between 0 and 90 degrees. So if I were to take that right triangle we just drew and put that in standard position, so starting from the origin, let me call the angle between the initial and the terminal side there, let me call that theta. Okay, let's give names to these legs and the hypotenuse. So the side that's right next to it, that's not the hypotenuse, let's call that the adjacent side. Adjacent just means next to. The side that's opposite, we'll cleverly call that opposite. And then the side that's opposite, the 90-degree angle, let's call it our hypotenuse. Okay, we have 6 trigonometric functions that are defined from this right triangle. Again, that angle is called theta. So the first one is called the sine, S-I-N-E, of theta. We can abbreviate that slightly by taking that E off of there, so sine of theta, S-I-N. I realize that sine has to be taken of an angle, so if I didn't have a theta here, that would be a sin. So always make sure you have an angle there because you have to know what you're taking the sine of. So the sine of theta is defined as the opposite divided by the hypotenuse. Something called a cofunction of sine, so it's called a cosine, again of an angle. I can abbreviate this by taking off the last 3 letters, so just the first 3, so COS, again of theta. That's defined as the adjacent over the hypotenuse. Okay, the next 2 cofunctions are called the tangent of theta. Again, abbreviating the first 3 letters would be just TAN of theta. And that's defined as the opposite over the adjacent. Its cofunction is called the cotangent. Again, of theta, first 3 letters abbreviated. Now, once you have these 3 trig functions, the next 3 are just going to be the reciprocals working back the other way. So the reciprocal of tangent is actually the cotangent, so I'm just going to reverse that order. So adjacent over opposite. The next set of cofunctions are the secant, again, of theta, abbreviated FCC. And this is going to be the reciprocal of cosine, so hypotenuse over adjacent. And then the last one, the cofunction of secant, so they're called the cosecant. Unfortunately, COS is already taken by cosine, so we go every other letter, CSC. And this is going to be the reciprocal of sine, so hypotenuse over opposite. Okay, so it seems like a lot to remember, but again, once you know the first three, the next three are just the reciprocals. So let me show you a quick way to remember the first three. If we look at the first letter of each of these, so the sign S, O, H, C, A, H, T, O, A. If we put all that together, we would have kind of a fun word to say. SOHCAHTOA. So the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then again the next three are just their reciprocals.